Now we are getting into what is called as lean concepts. Now, so there are several lean ideas that we shared in the last session. I also showed the outline of different modules that we had covered, because many Six Sigma methods include lean ideas to solve the problems and control the process. Now, I've already discussed it before. Do not have an open mind to learn. Don't think whether Six Sigma is better, lean is better, Scrum is better, business process reengineering is better, agile is better. Come with an open mind to learn all the methodologies. Okay, so how many of you have open mind? Type om in the chat box. Om. Open mind. Okay, great, superb, fantastic. Okay, now if you see, since I've been in this for 30 years, if Six Sigma professional, they will say lean is a part of Six Sigma. Okay, and if it is a lean professional, they'll say Six Sigma is a part of lean. If you call Kaizen professional, they'll say both lean and Six Sigma part of continuous improvement, and so on and so forth. So don't worry about that, but just have an open mind to learn this. Okay. So people often, since we are dealing with Six Sigma, we will put Six Sigma on the top and others underneath. Okay. People often use the term Lean Six Sigma when they describe a way to make the process better by using both Six Sigma methodologies and lean methodologies, Six Sigma concepts and lean methodologies. Because best results usually happen when you make a process better by getting rid of mistakes. And so it is basically, I tell this a million times, okay, whether you bake bread in the kitchen or make machines in the factory, process is a process everywhere. How many of you agree? Just type agree in the chat box. How many of you super agree? Process is a process everywhere. Okay. Please remember, I will reiterate one more time. Excellence is all about identifying activities in the process which doesn't add value, or simply identifying those not useful activities. We call non-value adding activities, and eliminate them. If not eliminate, at least reduce them. So when you remove the non-value adding activities, you can deliver faster and better. Okay. Similarly, even in the value adding activities, you cannot do it consistently in the same time. Okay. You cannot make a cup of coffee the same time that you made every time. There will always be a variation. And Six Sigma is all about reducing those variations. When you reduce the variations, that means it brings more stability, and then you can increase the capability. It brings better quality. And lean, when you eliminate waste or reduce waste, you take time out of the process, you can deliver it faster. So what the customer wants, all of you type QCD in the chat box. The customer wants quality delivery at an affordable cost. QCD, right? And delivery is a prime objective of, faster delivery is a prime objective of lean. The best quality is objective of Six Sigma. But if you deliver it faster and reduce, cost will automatically reduce. Okay, your process becomes efficient. Great. Okay, so whether you look from the business perspective, what does the business want? All of you type GPS in the chat box. GPS is business wants growth, profitability, and sustainability. Okay, any business wants growth, profitability, and sustainability. And only way that you can achieve this growth, profit, and sustainability is through customer satisfaction. And customer is satisfied. All of you type PQCD if you give them right products, best-in-class quality, affordable cost, and timely delivery. Okay, in order to give the right products, best-in-class quality, affordable cost, timely delivery, okay, you use Lean and Six Sigma methodologies. Okay, if you are clear about this on a scale of 1 to 10, please give me a 9 or 10 if you're super clear in what I've explained so far. Great, thank you very much. Let us go a little deeper. Okay, now quality, cost, delivery, right? That's what the customer wants. So a Six Sigma defect is when something, we already said this, right? A process does not meet the requirement, then it produces a defective product. So I'm going to discuss deeper in the later sessions when we talk about quality. Okay. But as of now, all you have to know is defects cost money. Okay. The language of leaders is money. How many of you agree with me? You ask your boss, he'll tell you the language of leaders is always money. The language of leaders is always money. Show me the money, right? STM, show me the money. Okay. So business also might lose money when defects hurt reputation, naturally, right? So making customers not want them to come back and buy from them. So don't do that. We should always improve quality. So from the customer point of view, defects can make it take longer to get what they want, okay, and make them unhappy with their product or service. So this is quite logical, quite understandable. Okay. Now, which means that if you have to reduce waste, you need to first find out what is waste. Okay, you need to find out what is waste, because if you waste something, waste is not something that we just put in garbage, okay, or that we throw into the dustbin. No, that's not waste. We are going to deal with other forms of waste, okay, because whatever takes extra time, extra work, extra material, this is all waste. It costs money. Whatever costs money is a waste. Okay. So waste is usually something used in the process that isn't needed for the good results. That's something you can say that as a simple definition. It slows down the process. Okay. And hence it delays the delivery. And hence it creates unhappy customers. Okay. How many of you are facing delivery issues in your, how many of you can relate to this? I'm facing a lot of delivery issues. I'm not able to, deliver on time. I can relate. Okay. ICR means I can relate, right? How many of you are suffering from this on-time delivery issues, right? Increasingly difficult these days, right? To deliver on time, and everybody is looking at delivery on time. They even say that how many of you heard about this McDonald's challenge? McDonald's challenge with the hourglass. Type me in the chat box if you heard about McDonald's challenge with the hourglass. Yeah. So anybody can share with what is that McDonald's challenge with an hourglass? Okay, let me share with you quickly. If you don't know, I'll share with you. Okay. McDonald's started this. Yeah, McDonald's started this. They said they have an hourglass there. You order something, and then if you turn, the hourglass probably takes about a few minutes for the sand to fall down. Okay. And if they don't deliver your burger, your French fries, or whatever that you ordered within that sand falling down, then it is free. Okay. How many of you heard about that? How many of you seen that? I have personally seen that. Okay. Same with KFC as well. Yeah. Okay. People started following that. Right. Okay. How many of you heard about Zepto? Zepto, right? Zepto. How many of you used Zepto? What is a promise? Zepto promise. Anybody knows about Zepto promise? Okay, great. So it's about 10 minutes delivery, correct? 10 minutes delivery. So Zepto, you order any groceries or whatever it is, okay? They have the concept of their own warehouse, plus they can access any other warehouse nearby. They are tied up with them, and make sure that they will deliver in 10 minutes. Okay, great. So all these discussions, I'm sure it is useful. If you found whatever that I've discussed so far is interesting, useful, valuable, please put in the chat box. I'll draw inspiration and proceed further. So we'll also touch on some lean ideas to make the process as efficient as possible. Great. Thank you very much. Right. So we are going into Muda. All of you, please write in your notebooks MUDA. You can also type MUDA in the chat box here. Muda. This is a Japanese word for waste. I'm going to discuss the 7 ways here, and there are also 8 ways. So if you want to know, take notes. I want you to take notes of 2 terminologies called DOWN TIME, downtime, and TIM WOODS, modes in your notebook. Okay, what is this downtime? What is this modes? Okay, and some of them are sending me, can you send me videos of these recorded sessions? Just a moment. What I'm going to share is I'm going to post this. I share it in the YouTube also. Just a moment. Okay, for those who also wanted these videos, I'm going to share. Please make sure that I'll share in my courses on YouTube from time to time, so you can be a part of this as well. Okay, great. Now I'm going to show you a picture, and we are going to enter into a lot of discussion from here. Okay, what do you see in this picture? I will explain about what is downtime through these pictures. Okay, and also Tim Woods through these pictures. Okay, now what do you see on this picture? What do you see on this picture? WIP, very good. Work in progress. Assembly unit, packaging. Overproduction. Okay, so now just to give you a heads up, I'm going to go back to this, and I want you to write DOWN, D as in defect, O as in overproduction, W as in waiting, N as in not utilizing skills, T as in transportation, I as in inventory, M as in motion, and E as in extra processing. So I'll ask you question, what is D? Please type in the chat box. D is defect. What is O? Overproduction. Okay. What is W? Waiting. Good. What is N? N is not utilizing resources. See, many books write not utilizing talent or skills. Okay. I say not utilizing resources. Why I'm saying? Because the AC is on, the burner is on. They just waste the resources. Okay. So I prefer to use it as not utilizing resources. No book gives here. If you write a book, you can write not utilizing resources. Okay. T as in, what is T stands for? Transportation. Okay. What is I? Inventory is a big waste, right? What is M? Motion is a big waste, right? Unnecessary motion. Okay. Whenever we talk about this, it is just that, whatever excess of it, more than needed. Okay. What is E? Extra processing. Very good. All of you give thumbs up to people who have written all this. Okay. Good. Now, coming back to this, the same thing. Okay, it is 8 or 7. Don't worry. I'll give you 10 also. Okay. This is 8 actually now. Earlier it was 7. So we have. Okay. Now, the same thing is, if you want to remember through Mr. Tim Woods. Okay. What does T stands for? Transportation. What does I stand for? Inventory. What does M stands for? Motion. Excessive motion. Okay. What does W stands for? Now there are 2 O's that are coming here. Okay. What are the 2 O's stands for? Overproduction and overprocessing. Very good. Good claps to those people who wrote overprocessing. There in downtime we say extra processing. Here we just say overprocessing, just to take care of that acronym. What does D stands for? I think D you must be knowing very well. That's defect. And what does the last one S stands for? Not support. It is skills underutilized. Okay. Underutilized skills. The skills that's not utilized well. Okay. Great. Fantastic. Now, with this background, I'll go to this one. What do you see? What form of waste do you see here? What form of waste do you see here? The predominant overproduction. Okay. Let me just explain to you here. Overstocking. Okay. Now, let me just explain to you Overproduction. What is overproduction? Producing larger quantities before necessary. It is not only in the manufacturing, it is also in the service industry. In the next session, I'm going to tell you what are the 8 types of waste in service industry. Okay. Overproduction is the most expensive waste that generate other waste such as excessive lead time, which makes it difficult to detect defects. Okay. Now my question to you is a sort of a quiz question. Okay. What happens? What are the other waste that is created when you overproduce? When you overproduce, what is the other waste it creates? Inventory is another waste, right? And also waiting is another waste. Okay. And you'll have to move excess transportation from one place to another when you're storing, right? And people will move extra processing, again repacking the whole thing. So, and skills underutilized. Some people, operators, are allowed to do these jobs, right? Who are supposed to run machineries. So, okay, right. So, overproduction is the deadliest of all waste. Okay, if I ask you the quiz question, which is the deadliest of all waste, it is overproduction. So, common causes of overproduction. Why do we overproduce? Let us see some discussions in the chat box. Why do we produce more? Why? High demand, poor planning, reduced cost, future demand, high rejection, improper planning, poor planning. Okay, there are a lot of comments. Okay, right. Now, what happens is, why do we produce? Let me share with you. The only thing correct about the forecast is that it is always wrong. How many of you agree with me? The only thing that is correct about forecast is it's always wrong. If you super agree, I super agree. Okay. So most of the forecasts are wrong. Okay. Now, because of the variation in forecast, we don't want to miss out on sales, so we produce more. In case there is a high demand, what do we do? So you produce more. Production at maximum capacity to maximize the use of machinery. I have invested in 1 crore machine. It is capable of producing 1,000 pieces. Why would I produce only 500 pieces? I will produce 1,000 and keep. Cost per component is low. Okay. How many of you can relate to what I'm saying? Type ICR in the chat box if you can relate to what I'm saying. Good. And overcoming the problems of fluctuating peak orders. Okay. Like the, what do you call it? Seasonal sales, right? Summertime, winter time, or Black Friday deals, etc., etc. So you produce more for it. If production means what happens if the machine breaks down? What if the people don't turn up? What if there is no raw material later? Okay, this material gets drained out. If type of production. How many of you can relate to this? Type ICR in the chat box. So we keep buffer on buffer on buffer on buffer. The stores people keep a buffer, production people keep a buffer. The planning person, while planning itself, gives a buffer, right? The salesperson, while giving the sales order, he will give a buffer. How many of you agree with that? Okay. Right. So somebody has said it's not possible to predict. I just wanted to let you know, just go through that flow. And all I want to say is, we are saying is, how much should you overproduce, or should we overproduce at all? And can we reduce it? That is the type of thinking that you should go in it. Don't come with a limitation of mind that, no, that is what the fact is. You can't help it. Don't feel helpless. Okay. There are some methodologies to overcome that. Don't feel helpless. Give me a 9 or 10 if you agree with me. Don't feel helpless. Okay. That's why these methodologies will be, have an open mind. You know, I've gone through 30 years to help you with this. Okay. Don't feel helpless. Leaders don't feel helpless. Leaders don't cry. Okay. That this is what is the situation. Leaders don't blame. Leaders don't justify. Leaders don't complain. If you are justifying, blaming, complaining, you're still not a leader. Okay, leaders find out options and they choose the best options and they keep improving on that. Okay, so optimal batch production lowers to cost and hence you end up in overproduction. Okay, now I don't know whether this picture communicates well. Which type of waste do you see in this picture? Inventory, huge stock. Right? They are not able to close the shutter also. Okay, warehouse is filled. Richard is very concerned. Do we have underproduction? Underproduction. Don't worry about Richard. Please go through this flow. I know you have typed some 10 times till now. Don't bother about that. Please go with the flow and understand what you have to learn here. Then at the end of it, you can ask questions. Okay. Now, inventory. If you see the inventory occurs when there are unnecessary levels of raw materials, many units, we call it as WIPs, work in progress, finished good, all of them use necessary good and use necessary resources, but finally piles up at inventory. Excessive stocks hide issues such as production imbalances, delayed supplier deliveries, defects, machine downtime, longer settings, and longer production changes and more. Let me explain to you this in a simple language. Okay. Suppose if you're having a lake, okay, imagine that there is a lake and there is enough water in the lake. You're on this side of the shore, you have a boat, you can easily go in the boat through this water to the next shore. Now there are some rocks under this lake. Okay, as long as water level is well above the rocks, okay, you can easily travel in the boat across the shore. If this is clear, just say clear in the chat box. Super clear? What happens if there are a lot of rocks under this? Suppose if the water level goes down, what will happen? Damage the boat. It will rock in the boat, right? So same thing happens. The same thing happens. You have excess inventory. If you have excess inventory, what will happen is whatever customer wants, you will keep giving, but you will not be able to find out whether there is any issues in the production because you are serving the customers with the material you have, but because of this inventory you will end up with a lot of cost. Now what happens is if you start reducing the inventory, you will save on the inventory cost, but the flip side is you will hit the rock, which means that there will be some issues, okay, that you will undergo, like the machine problems will get exposed. Okay, just to cover the machine problems, you will try to produce more, but now you have to address, you'll have to break that rock. The first rock you see is a machine related issues. There are only three things: material related issues, man related issues, machine related issues, and then method related issues. Okay, so each of these issues will get exposed and you'll have to break each and every one of them in order to swim or go in the boat safely from one shore to the other. Okay, so inventory hides problems. Okay, all of you type IHP in the chat box. Inventory hides problems. And I'll also tell inefficiencies manifest as inventories. How many of you agree with me? Inefficiencies manifest as inventories. You have inefficient planning, you end up in inventory. You have inefficient supply chain, you end up in inventory. You have inefficient forecast, you end up in inventory. You have inefficient machines, you end up in inventory. You have inefficient people, you end up in inventory. Inefficiency manifests as inventories. And if you reduce the inventory, inefficiency will get exposed. How many of you agree? Good. Okay. Now, okay, this is a little tricky one. What do you see on the screen? What waste do you see on the screen? What waste do you see on the screen? Idling. Wow, human. Okay, people are wasting time, right? They are waiting for something. Okay, they are waiting for something. So we know waiting is also a waste, right? Particularly when goods are not moving, not being processed, they will wait. So in a traditional batch and tail production, the longest lead time of products is closely related to waiting at each stage of the product for the next operation. They are waiting for material, they're waiting for something else, right? So common reasons is poor material flow, large batch production, capacity blockages, machine downtime, material shortages, longer production change times, no production plan. So these are the some of the reasons why this wait. Okay, next. Now let me check what does this picture tell you. What ways do you see in this picture? Okay, maybe this picture doesn't communicate well. Okay, we all know that defects are produced, right? And what is a defect? Any deviation that requires reprocessing of product or information. Okay, rejection, rework that we call. So cost of waste, quarantine stocks, reinspection, reprogramming and loss of capacity, and so on and so on. So these are the costs that are associated when you produce defect. And I'm not explaining this in length because this is mere common sense, right? I just wanted to cover the 7 ways today. Okay, now this is self-explanatory, I guess. What does tell you? Yeah, motion, right? Excessive motion. Great. See, motion is required, but how much motion is necessary? That is important. It's nothing but a physical movement that employee exercise excessively. Okay, not with material. Just to take one tool, they go to that place. Just to take a piece of paper, just to get approval, they go and stuff like that. Okay, so bending, stretching, walking, lifting, reaching something, searching, sorting, and all that stuff. And okay, what does this picture tell you? Is this picture interesting? Type interesting in the chat box if you find this picture interesting. So what does this picture tells you? Risk, okay. Extra processing, okay, great. Okay, so over processing, right? Using a sledgehammer to break a small nut. If it is just a peanut which has to be broken with hand or a small hammer, you use a big hammer and break it, right? So taking the steps that are not necessary to perform a process due to poor layout, arrangements of machinery, inefficient processing due to inadequate, poor design of utensils or products, and provide high quality or more control than necessary. Provide high quality or more control than necessary. This leads to over processing. This one is also explanatory, self-explanatory. What does this mean? What do you see on this? Transportation. Okay, fine. Okay, transportation. Excessive movement of material over long distances. Okay. So if you have inadequate transportation techniques or equipment, if you have incorrect location of this equipment, if you have large batch management and long distances between the processes, all that will lead to excess transportation. Okay, so I hope today you found today's session interesting, valuable, useful, fantastic, awesome. Just put it in the chat box.